Chapter 1. Introduction. This chapter covers what cryptography is about, theoretical versus real-world cryptography, what you'll learn throughout this adventure. Greetings, traveler. Sit tight. You're about to enter a world of wonder and mystery, the world of cryptography. Cryptography is the ancient discipline of securing situations that are troubled with malicious characters. This book includes the spells that we need to defend ourselves against the malice. Many have attempted to learn this craft, but few have survived the challenges that stand in the way of mastery. Exciting adventures await indeed. In this book, we'll uncover how cryptographic algorithms can secure our letters, identify our allies, and protect treasures from our enemies. Sailing through the cryptographic sea will not be the smoothest journey, as cryptography is the foundation of all security and privacy in our world. The slightest mistake could be deadly. Note: if you find yourself lost, remember to keep moving forward. It will all eventually make sense. Section 1.1. Cryptography is about securing protocols. Our journey starts with an introduction to cryptography, the science aiming to defend protocols against saboteurs. But first, what's a protocol? Simply put, it's a list of steps that one or more people must follow in order to achieve something. For example, imagine the following premise. You want to leave your magic sword unattended for a few hours so you can take a nap. One protocol to do this could be the following. 1. Deposit the weapon on the ground. 2. Take nap under a tree. 3. Recover weapon from the ground. Of course, it's not a great protocol, as anyone can steal your sword while you're napping. And so cryptography is about taking into account the adversaries who are looking to take advantage of you. In ancient times, when rulers and generals were busy betraying each other and planning coups, one of their biggest problems was finding a way to share confidential information with those they trusted. From here, the idea of cryptography was born. It took centuries and hard work before cryptography became the serious discipline it is today. Now, it's used all around us to provide the most basic services in the face of our chaotic and adverse world. The story of this book is about the practice of cryptography. It takes you on an expedition throughout the computing world to cover cryptographic protocols in use today. It also shows you what parts they are made of and how everything fits together. While a typical cryptography book usually starts with the discovery of cryptography and takes you through its history, I think it makes a little sense for me to kick off things that way. I want to tell you about the practical. I want to tell you about what I've witnessed myself, reviewing cryptographic applications for large companies as a consultant, or the cryptography I've made use of myself as an engineer in the field. There will be, almost, no scary math formulas. The purpose of this book is to demystify cryptography, survey what is considered useful nowadays, and provide intuition about how things around you are built. This book is intended for curious people, interested engineers, adventurous developers, and inquisitive researchers. Chapter 1, this chapter, initiates a tour of the world of cryptography. We will discover the different types of cryptography, which ones matter to us, and how the world agreed on using these. Section 1.2. Symmetric Cryptography. What is symmetric encryption? One of the fundamental concepts of cryptography is symmetric encryption. It is used in a majority of cryptographic algorithms in this book, and it is thus extremely important. I introduced this new concept here via our first protocol. Let's imagine that Queen Alice needs to send a letter to Lord Bob, who lives a few castles away. She asks her loyal messenger to ride his trusty steed and battle his way through the dangerous lands ahead in order to deliver the precious message to Lord Bob. Yet, she is suspicious. Even though her loyal messenger has served her for many years, She wishes the message in transit to remain secret from all passive observers, including the messenger. You see, the letter most likely contains some controversial gossip about the kingdoms on the way. What Queen Alice needs is a protocol that mimics handing the message to Lord Bob herself with no middlemen. This is quite an impossible problem to solve in practice unless we introduce cryptography, or teleportation, into the equation. This is what we ended up doing ages ago by inventing a new type of cryptographic algorithm called a symmetric encryption algorithm, also known as a cipher. Note: by the way, a type of cryptographic algorithm is often referred to as a primitive. You can think of a primitive as the smallest useful construction you can have in cryptography, and it is often used with other primitives in order to build a protocol. It's mostly a term and has no particular important meaning, although it appears often enough in the literature that it's good to know about it. Let's see how we can use an encryption primitive to hide Queen Alice's message from the messenger. Imagine for now that the primitive is a black box. We can't see what's inside or what it's doing internally. That provides two functions: encrypt, decrypt. The first function, encrypt, works by taking a secret key, usually a large number, and a message. It then outputs a series of random-looking numbers, some noisy data, if you will. We will call that output the encrypted message. I illustrate this in Figure 1.1. The second function, decrypt, is the inverse of the first one. It takes the same secret key and the random output of the first function, the encrypted message, and then finds the original message. I illustrate this in Figure 1.2. To make use of this new primitive, Queen Alice and Lord Bob have to first meet in real life to decide on what secret key to use. Later, Queen Alice can use the provided encrypt function to protect a message with the help of the secret key. She then passes the encrypted message to her messenger, who eventually delivers it to Lord Bob. Lord Bob then uses the decrypt function on the encrypted message with the same secret key to recover the original message. Figure 1.3 shows this process. During this exchange, all the messenger had was something that looked random and provided no meaningful insight into the content of the hidden message. Effectively, we augmented our insecure protocol into a secure one, thanks to the help of cryptography. The new protocol makes it possible for Queen Alice to deliver a confidential letter to Lord Bob without anyone, except Lord Bob, learning the content of it. The process of using a secret key to render things to noise, making them indistinguishable from random, is a common way of securing a protocol in cryptography. You will see more of this as you learn more cryptographic algorithms in the next chapters. By the way, symmetric encryption is part of a larger category of cryptographic algorithms called symmetric cryptography or secret key cryptography. This is due to the same key being used by the different functions exposed by the cryptographic primitive. As you will see later, sometimes there's more than one key.